I was working outside for the 2 days in a row that they closed the airport because it was too hot. Planes weren't rated to fly at that heat.
Wow.
Yeah. It was 122 in the shade. It was hot. All right. Questions about the anything 1 through 18? Yeah. 17.
Stop,
Alright.
Benjamin.
17. We got this triangle. You know, that's 15. That's 5x plus 2. That is A and B, and that is C. I don't know why I do that. So they tell us that A to B is proportional to B to C. We know that that's proportional 5 to 9. Okay, so A to B. So I would say that I'm going to take this length, multiply times 5. And then that goes along with this length multiplied by 9. Do that right? I guess we could just make that an equal. 5 to 2, 5 to 9. No, wait, what? Yeah.
Isn't it a 5x?
Oh, yeah, right here. 9. I was like, dude. All right, so what is that, like 75? Equals 45x plus 18. Did I do that right?
Yep.
And then subtract 18. That's 57. So x is equal to 57 over 45. Is that right? They came up with an answer of 5.
Yeah, I just got one. What I did was
Oh, that's not equals, is it? That's 2. So shouldn't it be 5 to 15 equals 9 to 5x over 2 plus 2? Is that right? Did I do that right like that? So 25. Just go with me, see if I can get there. What's 9 times 15? 5, 4, 135. 25x. Subtract 125. X equals 5. There it is. That was wrong.
I did it a different way, but I got the
Same proportion. Perfect.
I did like 15 over 5x plus 2.
Yep. And you know what? Today's lecture is actually going to answer why that worked. Any other questions from last night's homework? Go on. Yeah.
So when you solve the radical, you have like plus minus 6, and you said yesterday this is positive. Is it okay if we leave positive negative 6?
Yeah, and then we're actually going to find out today that x in this case, when we're doing the geometric ratio, always has to be positive. And it has to go along with this square root thing. But you're okay for now. It did say it on the answer key? Ooh, big, yeah. That one's okay. Because it's not related to a shape. That's why. Anything else? Yeah. 15. The length of the sides of the triangle are 2 to 3 to 5. And they tell us that the perimeter is equal to 30. So 2x plus 3x plus 5x equals 30. So that's 10x equals 30. So x equals 3. Or we just solving for x? Nope, finding each side. So you have a side that would be a 6. You'd have a side that would be a 9. You'd have a side that would be a 15. Yeah. 18. 18, just cross multiply so you get 35 equals x squared minus 1. I just multiplied it out. Is that okay so far? 36. X equals plus or minus 6. Okay, so just cross multiply, so 7 times 5 is 35, and then x plus 1 times x minus 1 is the difference between 2 squares, so x squared minus 1. Anything else? Going once, going twice? Sold to the kid eating his own earwax. I got to that Make sure your name is on it and pass it on forward, please. Yay. All right, ready? Item number one. Item number one. Who's not passing those back? Item number one. If you had two fractions, how do you know that they're equivalent to each other? So if you had like 3 over 4 and 6 over 8, that becomes pretty easy. Yes? Multiples, okay. But what if I had like x plus 1 over x minus 7 equals some other fraction just like that? How would I know they could be equal to each other? Any ideas? What? Cross multiply. So cross multiplication, if you have one fraction equal to another, and if you cross multiply them and you get equivalent statements, then they're equal. Okay? So think about it just in a general scheme. If you had 3 over 4 equals 6 over 8. 3 times 8 is 24. 6 times 4 is 24. This means that these are equal. But we knew this pretty simple. But if you had things like this, if you wanted to know if these were equivalent to each other, you'd have to cross multiply, and if you got exactly the same thing, not necessarily 24 equals 24, but the exact same thing equal to the exact same thing, then they're equivalent fractions. So we're extending our understanding of proportions and start applying this to problems. Is anyone getting too warm? Because I feel pretty comfortable. I know.
It feels so
I was so cold in my office because Mr. Mimak's window, I don't think he has one, and it's just like cold air. Love that guy. All right. So for clarification, by definition, geometric mean is always positive. So let's get to that. Geometric mean is always positive. The geometric mean, if we have a over x equals x over b, we're talking about the x terms. And the reason those have to be positive is because you have to take a square root. And when you're talking about that geometric means we're talking about shapes of some sort. Okay? Let's see. Okay, cool. How do we solve the proportion like a over b equals c over d? I have a piece of paper. That's what I wanted. Oh, wait, I'm going to go back one slide. Okay, so a over x equals x over b. So that means I'm going to get x squared equals ab, which means x equals the square root of ab. And a and b must be positive. Okay? So that's kind of just starting out where we're going to start going. How did I go from this step to this step? That would be, for those of you not following, root. This indeed goes with plus or minus, but then you only have the positive component there because we're talking about geometric mean. Okay, so how do we solve this? Well, we go a times d equals c times b. So some other ways we could write that. Exact same statement. I can do b over a equals d over c. How do I know that this is an equivalent statement to the original? Well, if I go b times c is bc equals d times a, which is ad, and AD equals BC is the same thing right there. It's just they have it in a different order. Okay, remember when you multiply numbers together, it doesn't matter if you multiply the first times the second or second times the first. So that's one equivalent form. Is there some other ways that we can make that equivalent? Remember, I'm trying to get to this this type of proportion. So can I switch more letters around? Could I go? How should I go? I don't want to go. What is it? You know what I want to do? Let's do this. 3 over 4 equals 6 over 8. Okay? So that gives me 24, 24. So what's another way I can get 24 and 24 rearranging my numbers? So this is these are equivalent. What else can I do to make it equivalent? Flip them, okay? That'll work. Don't move just this one over. Meaning don't go 6 over 8 equals 3 over 4. That's not equivalent. What else? Six over 3. 6 over 3 equals 8 over 4. 6 times 4 is 24. Yep. And then flip that. Cool. And again, the cross product of all of them are equivalent. So that means they're equivalent fractions. Okay. It doesn't mean that they are equal to each other because 3 over 4 is not the same as 3 over 6. But you know they're equivalent with relationships as long as we have the sides that way. So just by manipulating things around, getting the same cross product, that means you're dealing with these fractions are equivalent. These fractions are equivalent. These are equivalent. These are equivalent. This is not an equivalent statement to say this, because it's completely, different numbers. Talking about different relationships. Okay. So, where'd it go? Did I skip a page? It gave me a different page, right? Proportion true. Okay, we did that. Let's not worry about that. All right. So let's do the same thing here. So if I take this, what else makes it equivalent? We got B over A equals D over C. That's one of them. What else did we do? What is that? D over B equals what? Because I get DACB. DACB. And then the flip over this. B over D equals A over C. Again, works. Right? Yeah.
Could A plus D equals B plus C?
A plus D equals B plus C. I think we're going to get to something similar to that in a minute. Okay, so this gives me 8x equals 40. Cool. So we wanted to somehow do it the other way. So I know that 10 over 8 equals x over 4. Again, if I cross it, 40 equals 8x works. If I go x over 10 and 4 over 8, 8x, 40, that work? And then the flip over that. This is where math starts taking some weird turns. Okay? It starts talking about like number theory and why things are taking place. Something that's great out there is this. N equals 1 to infinity of the natural numbers. So the sum of all the natural numbers, you add them up, equals negative 112. Kind of goofy. That's a little bit out there. Goes along with string theory. And where you start having a hard time with it, going, well, if I had like a billion and added to another billion, it's going to be a really big billion. You're right. But we're not going and stopping at a billion. We're going to infinity. So this is one of those third year in college math type of thing. It's a limit that you approach. All right. I'm going to add a slide here. Actually, I don't need to do that. I can stay with this. Okay. Is it possible that these are equivalent? Okay. So, I have this. They're stating this is equivalent. So that's going to give you 5x plus 15 equals 3y plus 15. No, it's not going to seem logical to work that way. So how could I go from this, without doing cross multiplication, to start making it look like that? So let's just start, let's break this apart. Yeah.
You do the cross multiply with 5s plus 15 equals 3y plus 15 and start with.
I like it, but I'm going to take you a slightly different direction. Let's think about our understanding of fractions. This is fractions with common denominators. Obviously, that doesn't happen up there. But let's just take the left side. X plus 3 over 3. How can I rewrite that as two fractions, Johnny? X plus 3 over 3. How can I write it as two fractions? Just left side. Sammy.
Could you times it by 1 over 1?
Okay, yeah, a little bit. Emma?
X over 3 plus 1.
There you go. So let's take this one step back. X over 3 plus 3 over 3. Is that the same as this?
Oh, and then it cancels each other out.
And then that gives me, that would yield to x over 3 plus 1, which Emma said. And then what can I do to this to make it two fractions? It'd be the exact same thing. So that gives me y over 5 plus 1. And so now if these two things are equal to each other, what mathematical thing can I do to verify that x over 3 equals y over 5 is the same thing? Subtract 1 from both sides, so that cancels that. That allows you to say that x over 3 is indeed equal to y over 5, which, that was our starting statement. So, starting to understand that you can break a fraction down is okay to start, your mind's okay to start taking that. And I know some of you are not quite ready for it, but we'll get there. Yeah?
So, just to, okay, so you set x over 3 plus 1 equal to y over 5 plus 1, right? And then you subtract 1. That's it, okay.
Yeah, so the cleaned up version of this would be because that would have been 3 over 3, that would have been 5 over 5. If you subtract the 1s from both sides, then you get this. And that's a little weird thing about it. Fractions are a weird phenomenon. What is a fraction really? It's a division problem. Division, as it is, was the toughest thing really to come out of elementary school. Okay, why is that? Well, you're breaking things apart. Then you goof things up because now you have to start having remainders. And then some of you realize that you put decimals and you can start taking it into decimals. And then what happens from there? Sometimes they repeat, sometimes they don't. they repeat, that's good, because then you can find the terminating decimal. And in elementary school, it was like 9 or 9 or something like that. All right. So that was kind of just a snapshot preview of way bigger math later. Now I think we can go back and do this a little bit. So let's decipher some things that we could know. So I have AE. How big is this distance right here in relationship with the 3 and the x?
X minus.
Yeah, that would be an x minus 3 length. Why is that? The whole length is x. If I subtract 3 from that, I would get this remaining part. Okay? Let's see. Now, they tell me that's 6, that's 18, so the whole distance here, that should be pretty simple, just saying that's 24. Is that okay? All right, so AE is 3 over BE, which we called what? X minus 3, is equal to AD, which is 6, over DC, which they called as 18. So there's a couple of ways that you could try to solve this. The easiest way is just doing your cross multiplication. 3 times 18 is 54. And then 6 times that, I get 6x minus 18. Did I do that right so far? Add 18. So if I add 18 to 54, I get to what? 72? Is that right? Divide each side by 6. 12? All right, so if x is equal to 12, how big was this side? Well, this was 9, or this was 3, so this has to be 9. So, equivalent part over equivalent part. This also could have been worked out as this. Part over the whole, part over the whole, or part over the whole, or part over this whole. But in this case, we just did part over the part equals part over the equivalent part. Okay. This triangle here, this is stepping ahead a smidge. This triangle right here is similar to this triangle right here. Does anyone remember what it meant for me to say similar and not congruent? What's being maintained on similar? Go ahead.
They have the same angles, but usually they're bigger or smaller.
So the angles are maintained. That's exactly where we're going. So this is how, like a photograph, if you took a picture of your friend and you look down your phone, you know your friend is your friend by looking at the picture because the angles are all maintaining true, even though the size is different. That's why you can recognize people on a photograph when you have a scale image or a scale factor. Everyone all right? All right. So I know I have 12 to 28, so this whole length here is 40. I know that this is 8, this is x, so what's this side? X minus 8, good. So let's do our equivalent. SV is 12. VT, 28. I have the hiccups, excuse me. SU to 8. And UR, x minus 8. Cross multiply. I need help. 8 times 28 is? 224, thank you. And then 12x minus, what's 12 times 8? 92, thank you. 96, thank you. Add 96 to both sides. If I add 96 to 224, I get to what? 320, thank you. Equals 12x. Divide each side by 12, so x equals? Not joking at all. How much? 30? Does it go 30? 320 divided by 26 2/3. You said 0.6 repeating, right? So if that's the case, then I could find this right here. That'd be 26 2/3 minus 8. So that'd be 18 2/3. Sweet. Find SR. We have SR is 26 2/3. Find UR, 18 2/3. Yeah. You do it right? Comfy or no? Scared? You should be. Let's see. Hey, good. Yep, I match up with those answers. I like when that takes place. You doing all right on time? Eugene, you doing all right? You're hot? Oh man, I'm starting to sweat. All right, I'll take it. I'm not really. We'll take the. I'm sorry. I just had how to chill. Thank you for going through discomfort temperature for me. Okay, you buy a model boat. Oh, I like where this is going. The model boat is 20 inches long. The actual ship it is represented by the model is 30 feet long. The mast on the model is 13 inches. You have something to pull over? Oh boy. All right, should we convert inches into feet or should we convert feet into inches?
Feet.
Oh, come on, we could have went real complex. All right, so if I multiply this times 12, 30 times 12 is how much?
It's 360.
So 360 inches is the same thing as 30 feet. Still with me? All right. So the model is 20 inches long, the model. The model has a mast that is what? 13 inches. So we have inches over inches. Agreed? We know that the boat, the actual boat, is now 360 inches in length over X. Question. What units will my answer be in right now? Inches. Okay? 20x, thank you. And 360 times 13?
3,000
4,000? 680, thank you. Divide both sides by 20. So, 234 inches. How can I figure out that back into feet? Because inches kind of makes it goofy. You can't think about it. Divide by what?
12.
Divided by 12.
19.5.
How much?
19.5.
19.5 feet. Does that seem proportionally okay? If you have a boat that happens to be 30 feet long, it has a mast that's 19.5 feet tall.
Yeah.
That goes along with the 20-inch long boat that has a mast that's 13 feet. Sweet. How tall is the actual mast? It's 19.5 feet, or it's 234 inches. But know your units. Yeah.
What would the ratio be? 1 to 18.
I would go 20 over 13 equals 360 over x would be the great ratio for that. Are units important?
Yes.
Yeah. So, I had one of my pet peeves, and it's one of my wives too. One of my wife's. I shouldn't say wives. I only have one wife. I can barely handle that. We don't like. We don't like when incorrect units are used, and a lot of times this is done. I saw this at, what's the new store that took over the 7-Eleven? C-Store?
Oh, yeah.
They are offering sodas for that. I know, but it means something. Huh? What'd they say? I should just tossed a penny up there and then walked out of the store. I would have covered your lawyer fees. You get cuffed and stuff for walking on a soda. And then you can say, you're going to go to the judge going, but judge, this is not equal to this.
Yo, that's. You should like. You think you could sue for that?
Well, I look at it this way, Casey. If a woman could spill hot coffee on her lap and become a multimillionaire 10 times over because she wasn't warned that it was hot, 25 of the states of the 50 in the United States, it is illegal to drink anything and drive. Unfortunately, she was in the state that one of the states it was legal, but it would have been beautiful if she would have, scoured herself, where you don't want to get really hot stuff. And
McDonald's is making their coffee like way too hot.
Oh, yeah, well, which is, it's so silly to me. It's like, okay, water boils at 100 C, 212F, right? You really can't make water any hotter than that unless you compress it with pressure. You don't really change the boiling point of water by having coffee, though it might change the specific heat a little bit, but not much. But I'm telling you, for $17 million, I have no problem dropping hot coffee,
Oh, and by the way, she wasn't driving. She was just, yeah, she was just chilling in the car.
just chilling in her car.
Watch Adam ruins everything. Sorry.
Just chilling in her car. The one that, do you know that McDonald's got sued because if you go on now to McDonald's, if you ask for the quarter pounder, there's a little asterisk underneath that says this was the net weight before fried or before cooked. Yeah, because somebody went in and weighed the quarter pound patty and it no longer weighed a quarter pound, so it said you're misrepresenting what you're selling. Because the quarter pound patty no longer weighed a quarter pound because it had cooked away some of the fat, which had mass. Somebody sued. I mean, poor McDonald's.
Wait, but aren't they allowed to say that it's like 0.25 net weight when it's not cooked or anything, when it's frozen?
That's why they said down, the asterisk saying
Oh,
before
shit.
cooked.
That was
Wasn't there a whole thing with Subway about how their footlongs were 11 inches?
Oh, not 12 inches?
Yeah.
Could be. The world's crazy out there. Just crazy.
Everybody's trying to make an extra.
I tell you.
I'm gonna try that 7-3.
Now, all I need, if hang on, I think I have a penny. Will you cover me a penny? Buy me one,
Yeah.
too? Yeah, buddy. Go in there, put his 2 pennies down, saying I expect change. Buy 100 of them. Give him a penny, saying I'm out of here.
Yeah, I would.
That would be the field trip we should take.
Yeah.
There you go. Everyone
Yeah,
walks.
actually.
Everyone walks out with 3.2 sodas. Give us 100.
We actually, we can sign a form and everything and then walk over there.
And they're like, no, you can't go. No, that's what your sign says. No, that's not what we mean. No, that's what your sign says.
And then we can see.
I'm gonna call the cops. Bring the cops. All of a sudden, 9 News is here. Okay, so Mr. Stirrup, why do you say this is a good idea? What kind of representation are you teaching your kids? Decimal points matter. And then all your parents get you out of my class because you go, oh yeah, your teacher's crazy.
Don't worry, I'll stay.
You're like, but Mom. All right. Questions? I think you guys are set. Your assignment is 6.2. Show as much work as possible.
Do on Friday. 'Cause
Do on Friday because we're having a snow day tomorrow. Now I just jinxed it, and it's going to be sunny and warm. And I'm going to throw a big old rock through Dave Aguilera's window. He lives 2 houses from me.
Dave Aguilera.
Yeah. The What is that?
$1 a color that was sourced.
What's that?
My dad used to be a cop and he like rented a house in college. Right around
Right
here.
around there?
Yeah,
Oh,
so
alright,
that's
I
nice.
will. Dave's a hoot. Cause I always see Dave and I'm like, hey Dave, nice day. God, I shouldn't say that, he knows that. He's a weather guy. It's great. Dave,
Yes.
great abstract art. I guess I'm done recording.
No, you're not.
Okay.